Recording in progress. Hi, everybody. We're back, and this time we're going to talk about climate change. So let's start from the beginning and get started here. Let me share my screen. Share my screen. Okay, so first of all, we're going to talk about what we know about changes to the climate that have occurred so far. So earlier on in the class, we talked about how greenhouse gases impact the temperature of the atmosphere by holding infrared radiation and keeping the climate warmer. And so people have been studying changes to greenhouse gases, the biggest culprit being carbon dioxide in the atmosphere, for a while. We have records going back to about the late 1800s. We also have data going back there with temperature records. But the most comprehensive data set that we have is this famous data set that has been collected on the Mauna Loa volcano, which is out on the Big Island of Hawaii in the middle of the Pacific Ocean, and has been recorded since the late 1950s. And it's called the Keeling curve because it was set up by this father and son team, the Keelings. And the value of carbon dioxide in the atmosphere changes seasonally with winter to summer as there's more decomposition in the atmosphere or photosynthesis in the atmosphere, pulling up and down carbon dioxide. But regardless of those kind of interannual changes, those little bumps that you see every year, it's very clear that the concentration of carbon dioxide has been going up in the atmosphere steadily over the last almost 100 years. And we can also see, if we look farther back in time, not with records that were measured with humans with specific instruments used to measure carbon dioxide, but with other kinds of proxy measures, where we're looking at things like ice core data and whatnot, which we talked about also earlier in the class, that this current state of affairs, where we have over 400 parts per million, about 420 parts per million carbon dioxide in 2023 when I'm recording this lecture, that concentration of carbon dioxide in the atmosphere is way out of the range of the variability that has been existing on the planet for the last million or so years. And this is particularly important if we think about humans, because anatomically modern humans have been around on the planet for about 200,000 years. And so we've basically doubled the concentration of carbon dioxide in any time that humans have been able to live successfully on the planet in the past. So that's a pretty big change that we've seen. And we bring this up not because maybe necessarily care about the concentration of carbon dioxide on its own, although it can have impacts like changes to ocean, pH, acidity, and things like that, but mostly because of its correlation and connection with temperature. So if we move to the next slide, which it's not letting me do here, it is important to remember that the Earth has always been changing. It's been around for a long time, about 4.6 billion years. And so the Earth has been a lot colder and a lot hotter before. So sometimes you'll hear people say things like, wow, this is the hottest the Earth has ever been. That's not true. The Earth has been a lot hotter. If we go back to times like a few million years ago, we had conditions where the Earth was several degrees Celsius warmer than today. And even if we go back times about 200,000 years ago, 400,000 years ago, we had some warm periods where the Earth was slightly warmer than today. But it's also important to remember that during these times when the temperature was different, the conditions on our planet were really different too. So if we went back many millions of years ago to these warm times, we would have had sea levels that were covering large portions of the United States with ocean. So yes, it's definitely true that the Earth has been warmer and colder before, but when those temperatures have been different in the past, the conditions on the Earth have been very different. And that's one of the things that scientists are concerned about is, hey, if we're changing these conditions, then we should expect or we're changing these temperatures, we should expect the conditions around us to change alongside them. Okay. Oh, my computer is really freezing. Okay, we're gonna skip this for now. But so as I mentioned, we have thermometer data where humans have used thermometers to take very careful records of temperatures all around the planet, dating to the kind of late 1800s. And when we have data for temperatures before that, we're looking at proxy data where we're not actually looking at data measured with thermometers. We're looking at other kind of indirect variables that help us understand what the temperature was like. But from these direct thermometer measurements, we have these really comprehensive records that show us how the temperature has been changing alongside these shifts in carbon dioxide since the 1880s. And we can see that for the first several decades in the late 1800s and early 1900s, the temperature wasn't the same every year. It's never the same every year. There's a lot of variables that go into determining temperature, but there were some high years and there were some low years. And then as we start to kind of come into the 1950s, 60s, and beyond, we can see that the temperature has been very steadily climbing. And so, and on this particular graph, these numbers over here are showing the departure from the average temperature that was experienced from the beginning of the data set, 1881 to 1910. So like the first 30 years, what was the average data over the first 30 years? And then in some cases, the temperatures during that time were lower than that average, and sometimes they were higher than that average. And then over the last century, we've seen that basically these temperatures have been increasing so that now we would never see a temperature where it's going to be lower than the kinds of conditions that we had in the late 1800s. So it still varies from year to year. We might have a slightly hotter year and a slightly less hot year, but they're all significantly hotter than the kind of thing that we were looking at 100 years ago. And so because scientists and politicians have been concerned about this trend in global warming, starting in the 1980s and at 1988, they started an organization that's called the IPCC, or the Intergovernmental Panel on Climate Change. And this is a group that works within the United Nations Environmental Program, and basically is a collection of a lot of the world's top scientists. So it's not just a US thing, it's something where we have people from all different continents and countries on the planet working together to study climate science and to make these regular reports out that then can be used by people that are making decisions about policies in countries all around the world. So the goal of this organization at the IPCC is to synthesize and present the best science on climate change to inform policymakers. And so the most recent report that was made at the time that I am recording this particular lecture, which is in 2023, was this synthesis report on the kind of 6th major assessment that they've done since the time that this organization was put together in the late 1980s. So they continue to collect data, and one thing that they have been very clear about as they have been presenting data recently is that the warming of the climate is unequivocal, meaning there's no debate about the fact that the temperature of our planet is warmer. And then another thing that I don't have in here is that it's very clear that humans have a role in creating the conditions that are driving climate change. So what are some of the things that we've seen so far that allow them to make statements like this, like that the warming of the planet is unequivocal? Well, we've seen that the average increase in temperature on the planet is about 1.2 degrees Celsius. So far, we saw that 2 slides back. So that's a Celsius is equivalent to about 2 degrees Fahrenheit. So that's more than 2, about 2.5 or so degrees Fahrenheit on average warmer than it was at the beginning of that record keeping time in the late 1800s, so a little over 100 years ago. And they have a lot of different kinds of figures and graphs in these reports. But one of the kinds of graphs and maps that they have been including in the most recent reports are these kind of pseudo maps of the world that show places like North America, South America, Europe, Asia, Africa, Australia, the South Pacific and whatnot. And you can see within these different areas whether different kinds of climatic variables like extreme hot temperatures have increased in these different colors based on the variable, decreased, or there's not really a consistent read on how they've changed. So you can see for temperature, in almost every single part of their planet, we have seen an increase in these extreme hot temperatures over the 1950s, and then the dots tell you how confident scientists are about those changes that we've seen. So a lot of dots here, a lot of pink here. So knowing that the planet is on average getting warmer is something that we see really clearly in the data and we have a lot of confidence about. Other changes we expect that will come along with temperature and climate changes won't just be temperature, but will be things like precipitation changes or potential drought changes, and so on and so forth. There's a lot of things that we could include here, but here's just one other variable included for reference, also from the same 2023 synthesis report. Basically, this is showing how temperature might change. And so in the case of temperature, the changes that we're going to see are going to depend on a lot of variables that we don't necessarily know about the future yet. But one thing that we think will likely happen is that dry areas will get a little bit drier and wet areas will get a little bit wetter. But one of the things that we definitely expect to see and have already seen is that the amount of precipitation that occurs in areas tends to be more concentrated in fewer events that are more extreme. So you might have fewer days of rain throughout the year, but then when that rain comes, the rain is really intense. And that's because the warmer temperatures in the atmosphere can evaporate more moisture. They can hold more moisture because of their higher water holding capacity when they're warmer. And then when something changes in the atmosphere so that it starts to drop the water, there's more water that can be dropped all at once. And so we've seen these in some pretty intense precipitation events already occurring so far. And so these graphs that I'm showing you right now are not about the future. This is just about like what we've already been observing. And so you can see that this isn't quite as strong as a signal as that we saw in the temperature, but there's a lot of areas on the planet that have been seeing much more intense precipitation associated with climate changes so far. And this is a trend that we expect to continue. Okay, I'm going to stop there and then I'll record another video next about our future predictions.